Hello everyone, I hope everyone is doing well. So our today topic is OSI and TCPIP model. Actually guys, I should have said this before starting the video, that entire network is going to be run on this models, not two models, because one of them, the OSI model, is not a implemented or practical model. It is just a reference model. Reference in the case, it's just used while when you want to explain, or when you want to uh, go deeply in the concept of communication between two pieces. So in order to separate each, I can say, each layer independently, or each layer really explicitly, so we use OSI model because it separated out the entire communication in more than number of models than TCP/IP. But the TCP/IP is a practical model. Practical and means or implemented model. So actual communication in this current world right now is going to be done in TCP/IP model, which is based on IPv4 and IPv6. You will notice later. It is the actual implementation. So practically, we are using the TCP/IP and referencing, or I can say just occasionally we are using this OSI model just for referencing. So what are these two model? The next question is, why these two model? Before answering the what question, I think it's better to answer the why question. Guys, there was a problem in the communication. For example, when the two PCs want to communicate with each other, for example, there's one PCA. There's one PCA, one computing device. So that computing device could be a computer, your laptop, your desktop, or another device. Actually, guys, if you want to know what is a computing device, the proper definition of a computing device is a computing device is a device which contains specific four things. Actually, guys, these are really compulsory for a device to be called as a computing device. The first is processing, the second is memory, the next thing is the disk. For the memory is, like, I can say the memory for just for exactly that RAM which you are calling, or temporary or volatile storage. So storage, and disk, which is permanent storage. I think it's better, or non-volatile storage. So volatile means like RAM is like until it is up and running, so it can store the data. Otherwise, while the device is off, nothing. And the last one, which is really important, which is one of the important devices items, is NIC, or network interface card. Network interface card. So for each computing device, these four things are mandatory, compulsory. Without these four things, we cannot create a computing device. The problem was, guys, what was the problem actually? Why these models are created? Suppose there is a company, for example, IBM, or let's don't go for IBM. Actually, let's go for a reference name. Okay, for example, AAA or XXX, whatever you name it. For example, company IBM, and I'm talking about the past. I'm talking about the history. That when suppose IBM created a computing device for itself, then there was a condition that the CPU should be also related to this XXX company. The monitor should be also related to this company. So keyboard, everything, actually, guys, all the devices which are going to be used for this computing device, for this PC, must have to be from the same company, the XXX. For example, XXX is right now, for example, IBM, let's say. And there was another company, there was another PC which was related to the, for example, another company let's say digitals, or let's say our reference name, so that we cannot use so that we don't use I think it's not good to use the specific company name. But as before, so you can search which company were in the before, who was right now even there exist. For example, IBM, Lenovo, so many companies are existing right now. So the thing was like, if the triple Y product was there in the market, so the triple Y product have to be used with the same monitor, with the same keyboard, with the same every related equipment. So now the difference is, suppose if these two companies, if for example right now even the operating system, so even the operating systems was also some of the mandatory things. Now if you want to create a network between these two PCs, okay, so if you wanted to create a network between these two PCs, they were not able to communicate with each other, because they said if the product is from IBM or if the product is from the triple Y company, then all the equipments and all the network partners, or all the network partners, it's better to, as a better term to use, so must be from the same company. Their operating systems must be from the same company, from the same brand. So otherwise we cannot establish a communication between each other, because our architecture is different, and because there was a different problem was, or there was a different architecture, or maybe different design, different product, so many things. There was mismatch, because one computer, the one brand used to create theirs. Even right now also, for example, a mobile device, let's say Apple has its own design and architecture, whereas the Samsung has its own device and architecture. So when two different devices want to communicate with each other through a network, so there should be a mechanism, so that we should despite of being different architecture, we should communicate, because in this world we will not find same things everywhere. So when you want to communicate with another device, it shouldn't be any condition or constraint that the second device or the opposite device must be from the same company. So we should create such a model, so that two different devices, so two different networks, two different things must communicate with each other, irrespective of any conditions. So for this purpose, guys, they have made a really good model. Actually, they have made a standard model. The first model was with OSI, which was created by ISO. You are aware with the name of ISO. So ISO has made this OSI model as a standard model, so that every company should use this model while communication. And ISO, but it was not implemented actually. The actual implementation was done through TCPIP, but ISO has separated each step of communication very explicitly, and very explained. But the TCPIP has collapsed through three differences there. It has collapsed first three layers. So we will know. Just wait for some time. So they have created this OSI model, which was the actual implementation of TCP/IP model. So it was not actually implemented. Actual implementation was done through the TCP/IP model. How? I will explain this, guys. So let's see what was the OSI model's layer and what the OSI model says. How? What was the rule of OSI model? I have made a just a really simple pencil drawing. Guys, for suppose there were two pieces from different two companies, and they were connected through in every computing device you will find the network interface card inside the maybe if it's a desktop, you will see the network interface card inside your box. If you open your box, your CPU box, so you can see the network interface card really available there. And in your laptop also, if you open your laptop through any screw on anything else if you want, so you can see the network interface card, and depending on the brand, is located somewhere in your laptop. So while you're connecting two devices, so you're taking a cable, a medium of connection. There are so many cables on a medium of connection. I will explain some of them. But for example, there's a cable. Okay, they can be connected wirelessly, and through a wire. Wire is a different technology, and wireless is another different technology. By the way, in network interface card, it has been teached, or I can say it has been born in such a way so that when it receive a cable, so it means that it's going to be connected with some other device. So these two pieces are connected through their network interface cards with each other through a cable. Let's say this cable is an Ethernet cable. Let's say this is an Ethernet cable, and so connectors are used in both the size RJ45 or other. So there are so many connectors available, which the most popular one is RJ45, which is used for the LAN, usually for the LAN purposes. So let's say, guys, these are two PCs, PC1 and PC2. Let me name it as PC1 and this as a PC2, so that we can understand, we can differentiate the things. Guys, the process is actually inverse depending upon the sender and receiver. This is the sender and this is the receiver. Okay, suppose I'm just giving an example. Suppose this is the sender and want to send let's say an image, okay, a photo, an image, and obviously that image is in the format of .jpg, let's say. This PC1 want to send the image file to the PC2. The first thing which this PC1 will do, for example, in your country, in your computer, you want to send the image or a file to your friend. So you first of all decide that through which application. First of all, what you're going to do, you're deciding that through which application you should send this you should send this image to your friend. So they will ask that send me through WhatsApp, or send me through Messenger or Facebook Messenger, or send me through an email, whatever you like to do. Okay, so the first thing which you're dealing with is the application. This application is not all the application, actually, guys. These are those applications which deals with the internet, deals with network or internet. So as a technical, you're using internet as a network. So everywhere I'm calling the network. So internet is also a network. So don't be confused on this part. So all the applications which deals with network or internet. For example, which applications are dealing? For example, we have so many applications which are dealing with, for example, Chrome. Chrome, for example, Firefox. Or through this Chrome browser, you're just opening your WhatsApp, or maybe there's now companies are producing the actual application for their communication. So, for example, you have downloaded the WhatsApp application in your mobile, your computer, what doesn't matter at all. So you're selecting your application. So in the first part of communication between two devices, irrespective of it is a laptop or it's a desktop or it's a mobile device or any other device, but it's a computing device. It has its own neck. Until we don't have neck, we cannot establish any communication, guys. So you have selected and you have put your image. Then what happens is, guys, in technology, everything is binary. Okay, everything is what? Everything is binary. Okay, let me write some draw something here. So this is your data. I should write this because it's important to you understand. This is your image data. Okay, also I will write it data, which is actually your image. Now your data is an image. So what you're going to do is, in the presentation layer, since every computing device deals with binary, it cannot understand anything else. So it can just understand 01 and 01, this type of binary. So you have already, if you're a bachelor student in technology and IT, computer science, whatever field related to technologies, you already know what is binary. So in computers and technological devices, it deals only with binary numbers. The second operation or the second task, which is going to be done with the help of I didn't put the title here, guys. Let me put the title OSI model. It's the OSI model, guys. So not the TCPIP model, okay? It's just reference model, OSI model. I'm sorry that I forgot it. Okay, so now the job of presentation layer is to encode Encode this data. Encode this data. What to encode? Encode this image .gpg file or .png file or any type of file. We have so many type of .gpg, .png. We have, for example, we have .txt. So many type of files. So you know all of them. It encodes this file, this data to what? It encodes to 01 and 01, okay, depending on using the technological systems or using the logical operations. So it encodes this. The second thing actually which a presentation layer do is also the encryption and decryption, guys. Encryption and decryption. Encryption decryption is a security concept. You will understand it in Ccna security and the further security studies. So it will also do the encryption decryption part using technologies like TLS. We have SSL. So many technologies are available. So using these technologies we're using, if you want to learn about these technologies, you can refer to Ccna security to understand this. So using this technological protocols, so they're encrypting and decrypting the data for us. So the data the data format will be changed totally. So again 0101, it's I'm not saying the data will change from binary to something else, but the content of the data will be longer depending upon on the number of on the size of the encryption key and the size of they are really critical concepts, guys. So it will add some encryption on that or decryption depending upon the application choice. If the application is a secured application, so it will add definitely. The job of session layer is that this job actually, guys, the job of the session layer is to establish the connection or to and maintain the connection. For example, there's a mobile device. You have your mobile device and you want to communicate with the server, okay? You want to communicate with the server, and the server is saying that if you want to communicate with me, you should authenticate yourself with me. So to establish this authentication, to establish this connection, we should authenticate with the server. So the job of session layer is to establish the connection, and then while the authentication is done, then for the further requests. For example, the first request you want to watch a video. The server asks you first to authenticate, then you watch the video. Suppose you authenticated yourself and you want to watch the video, and the next time and after finishing of that video you want to go for the next video, for example. So your expectation is that server shouldn't ask you for the second time authentication, because it will really disturb you. Now the solution for this is the session layer. The session layer maintain the session between you and that server, so that it keep the track that you are already authenticated user. So there is the connection is already established, so there is no need to re-authenticate kind of stuff. So for maintaining the connection and for maintaining the state of connection, guys, so it maintains the state of connection that will be useful for the user. So still our data is the data bus right now. But still that data, there's no change in our data except the format of data is changed in the binary and the 0101. So now our data tell here is 0101 data, guys. 101010, whatever it is, depending upon the conversion. So now it comes to the fourth layer, guys. That is a transport layer from the receiver side. When you are sending your image, your movement or your direction is from up to down. So your direction from the sender is from up to down. Let me just show you guys here that your direction is from up to down. Now you came to which layer? You came to transport layer. The for understanding the transport layer, guys, it has really so many number of jobs which is doing. Please remember what I'm saying. If you forget it, I recommend you to watch the video, because it will give you the overall idea of how the connection is, how the communication is done. But deeply for your further studies, all our network concept going to be for depending upon these layers, which protocols are working in for application layer, which protocols are working in presentation sessions, transport, network, data link. So you will actually, the entire concept of network is this only, but for your brief information, I'm giving all this information for you guys, so please remember this. So actually guys, in the application layer, for example, right now I named protocols, so there are different network protocols which are working in application layer. So as a brief introduction, it's not good to name all those all those protocols, for example HTTP, DNS, FTP, what they are doing, what they will, how they are going to communicate. So it's a concept of further studies, but in each layer different type of protocols are going to be work. Okay, so now we are in the transport layer. Let me explain you what is transport layer, guys. Okay, suppose guys there is a server, Facebook server. uh, you know, the server is a really high configuration device. Okay, and you have your mobile phone. It's your mobile phone, uh, and you have established your communication between the server. So how the communication established, you already know this, guys. As a brief, you're living in somewhere in your country, you got your internet connection, maybe in your SIM card, or maybe you're having your ISP connection in your an access point in your home. Your Wi-Fi communication I'm talking about. So your Wi-Fi is connected to there. You should have watched the previous video of my second what is the network, how the communication between you and your Facebook server, Google server is established. So I explained in the second video. So your communication is now established with server through the help of three ISPs, through tier ISPs, tier 1, tier 2, tier 3, and so many information I had given to you. But the thing is, for example, you want to upload or you want to download a video of your friend who has posted a video and and Facebook. There's the video of your friend, which the video size is for example 1 GB. You want to download it through in your mobile phone. So first of all, you will go to some application in your mobile phone, for example some downloader. You will go to some downloader application, which is and this downloader application use we have said that first of all you will go to the application layer. Okay guys, so you are going to go to downloader application, and downloader application uses its own protocols. For example, for downloading purpose we use FTP protocol. Don't wonder about this if you don't know what's FTP. I'm just giving as an example. So because multiple protocols are used in different areas. So downloader, you're going to download it, and you're putting the URL and you're downloading the video. The Facebook server has that much capability to send the 1 GB in 1 second. Let's say it has that much ability which can send the data to your mobile device 1 GB per second. But the thing is that your mobile device currently mobile device don't have that much capacity to hold that much large information, because it can only take up to maximum 10 MB, guys, isn't it? So depending upon your mobile device, we cannot compare a mobile with a server. Okay guys, so now there's a problem. So how to solve this problem? There is a conflict between two devices. The solution for this is that we will take the help of transport. We'll take the help of transport layer. What this transport layer will do for us? It will do segments for us. Segmentation is the first job of the transport layer, which will segment our data and multiple pieces, which we call it as a segment. So a data of 1 MB, 10 MB, or 1 GB will be segmented in multiple. For example, a 1 GB data will be segmented. Let's say I'm just giving for example this much amount of, let's say it's just an example segments, for example. So each segment because now every segment between phone and your server has that much amount of value, or that much amount of size, where the phone and the Facebook server, both of them are agree with it. Both of them can process it at the same time. And in order to keep the track of the segment, we use sequence numbers. Okay, so there is a sequence number that this is this is a segment number 1, this is segment number 2, this is a segment number 3, and so many other segments. So for this is the first job of the transport layer, guys. So it will do the sequencing for us. And the next job of and this I'm not saying that's the next job, but it's one of the things which the one of the things which the transport layer is doing at the sequence. And the second thing, it will add port numbers, guys. Port numbers. What's the port number for source and destination? Source and destination port numbers. The application which you have used in your mobile phone, you use downloader, okay, or maybe your WhatsApp to send some image. That application in background, if you have a knowledge of programming, every application uses a port number in order to operate. If you have a knowledge of programming, how a software is built or programmed, so in your codings, I have the knowledge of programming, so I'm saying this, but it's not under our concept. And while coding that application, while creating your application, you're using some ports in background of that application. So that transport layer will also add, along with sequence number, it will also add the source port number of the application who has requested for a service, and the destination port number of the service which your mobile phone is using, guys. So these were the two things. Let me add in our packet. So in our packet we have two things. We have our we have the sequence number, we have the source port, we have the destination port. Okay, let's say this destination port, consider it as a destination port, guys. And along with that, so and our data is our segment. Now the data is not the complete data, actually it's a segments, in a format of segments, guys. So segments, this is our segments, guys, because the entire data is really huge. So per segments we are just sending the data. It will add these two things. And the protocols which the transport layer is using is not that much protocol, so I can name both of them. There's not so many protocols, it's only two protocols, the TCP and the UDP, guys. What I'm saying is, what is the TCP and UDP? For example, this was our data. Now if depending upon your application, for example, you're using your WhatsApp, and WhatsApp has built the programmers has built WhatsApp in such a way, the programmers knows that WhatsApp is really important while you want to send a picture for someone. So you want the picture or you want the message should be delivered successfully without any problem. So you should be assured that your image image to your friend has been sent. So that the programmers are making the WhatsApp in such a way that it should use the TCP or UDP in the transport layer. What the advantage will give for you guys? What is the advantage of TCP and UDP that programmers will get? If the programmers use TCP, it means that it's a reliable. Reliable means that your data is successful. Your data transmission is successful because it gives you a feedback, guys. What do I mean by this? That TCP is a protocol and transport layer where it's reliable. It gives you guarantee by how it gives you guarantee by giving acknowledgements. For example, when you are sending the segment 1, you will get the acknowledgement of segment 1 by using what? By using acknowledgements. When you are sending the for example the segment 1, you will get the acknowledgement. You will get the acknowledgement of segment 1 back again. So through this sent and acknowledge, it will guarantee you that your data has been sent. So it depends on the programmer and depends on the on the application which you're using. For example, uh, there's a, for example, there's a communication. For example, there's a application which used for voice call. Let's say there's an application which is using for voice call, okay, or video call, doesn't matter. This application, is it really important when you are voice calling to someone and you said something for him or her, but she didn't hear that clearly due to some noises, let's say. Is it important for the application to retransmit data back to her? Obviously not, because yeah, that she will ask you that I didn't hear you properly. Can you repeat yourself? It's you actually which send that data again. It's not the application which, while you are saying hello for her or for him, it should keep remember of your hello. Then once the application send your hello to that person, so the application should wait. The application should wait till the response of that person to say hello back again or kind of a stuff. Obviously not. It's a voice call. It's a video call. So we cannot acknowledge for the protocol that please tell him that I have received your hello. What you are saying is again, how are you actually? We are not responding anything kind of a stuff. So, and voice call, video calls, video streams, it really doesn't matter if you are sometimes due to noise or due to some buffering, you're missing some kind of information. You, because you will ask again back your friend that what you said just because of noise I can't hear. But there are some of the protocols, but some application which, for example, you're sending a message, you're sending an email, so it's really important that all your mails should be delivered there successfully. No portion should be missed, because if anything missed, then the actual message or actual point will not be clear for him, because he or she will not ask you back again kind of stuff, because it's not a live communication. So depending upon the application, it really depends on the first layer that which service that application wants to use and transport. If it uses TCP, it is the successful guarantee and gives feedback that the data was successfully sent and the guy has received it properly. But if it's UDP, it's not reliable, guys, unreliable, because it will not give you feedback. When it's sending the data, it will not give you feedback back again that your data has been sent or not. So these are two type of services, but there's a difference between these two. The UDP has an advantage for you, that's faster, guys, because it gives you no acknowledgement. The data transmission is really fast, but the data transmission comparatively slow, because it gives you the feedback also. Guys, if you have a question kind of stuff, that if the data, for example, if the data missed during the sending, how the TCP will give the reliability that the data is missed or not missed, or if it missed, what will happen then, guys? So it's again really a huge concept. uh, if I go deeply in packet level, it will you will be shifted to CCNP or CCIE level, but as a CCNA level, it's enough for you guys. But I will give you a little bit hint that once the data is sent, suppose some data has been missed, then the opposite side, the receiver side, how it keep the track, it will keep the track through the sequence number, guys. It will count the sequence number, and then if he found something missing or sequence number does not exist, then it will request back again that the sequence number 2 is missed, so please send me back again. Okay, so through the sequence number it will keep the track of that, and also to, so I'm sorry, through the checksum, guys. Actually, it's also not wrong to say through the sequence, because actually the term is through the checksum, but how the checksum is calculated is obviously calculated through the sequence number, through the segment size, through different type of features, bits or exist in the checksum calculation. I'm really sorry that I said like that, but through the checksum, it calculates that whether something is missed or not. And how the checksum is calculated, using the different bits. Checksum, if you want to see the checksum header, it's also in the CCNP or CCI levels, because we should capture the packet, which is through Wireshark. So it was all about the transport layer. Now, in the network layer, guys. So in the previous video, I said you guys that when internet is a network of network, and when you're living in your country, so depending upon the size of the network you're here, for example, if it was if it's a world, okay, guys, if it's a world, okay, and you're living in a specific country, for example, and that the specific country has its own specific ISP which you are using actually, for example, let's say. And now the thing is, guys, that you're using your own network, that simple small network which is your ISP, but the world is not your network, okay. For example, where you're living exactly, the server of Google is not located beside you so that you can access it very easily. The server of Google is obviously located somewhere else in the network, and in this internet world. So what I'm saying is that network between two PCs, you will understand it later on very specifically, depending upon the subnet. You will understand it, guys. Depending upon the subnet, we are differentiating, or we can say we are classifying the networks, that whether you are in my same network or you are in a different network, guys. Depending upon the subnet, we are classifying that you are in the same network or different network, you and Google server. So you will understand the subnet, please don't worry. But what I'm saying is that when you are using internet, it doesn't mean that the same internet is going to be used by the Google server. Actually, the network's classification and your network area, the subnet which you exists right now and using your internet, is in a different network subnet, and the Google server is in a different subnet. You are communicating with each other where in such a way that you are using totally two different subnets. So but how, if you say that if I'm using different, if I'm communicating with different subnet, then how my network knows that how to reach there? This is the job of who? This is the job of network layer, guys. Network layer. The network layer will what is the job? What it will do for you guys is that it will add a number for each subnet. It will add a number. That number is logical number, which is called as IP address, guys. IP address. So it will give an IP address for Google, an IP address for Google, and an IP address for you, IP address. So when you're communicating with Google, the network layer will add your IP and the Google IP, so that once you send your packet to the Google should know that this packet came from which network, whether it came from my network, the Google, and the network which is run inside the Google data center, or it came from somewhere another from the world, maybe from India, from US, from UK. So communication, obviously you're living in different areas, so you're using different network ranges. So this IP will connect two different networks located with each other. How? Through the using IP address. So we will have so many lecture videos about IP addressing, which is really important, guys. So please bear with me. As I said before, that this tutorial is really helpful for you guys in order to teach you an organizational level of studying, and once you finish this course, you should have that much knowledge to work around in other companies. So you're using your IP address in order to differentiate yourself. So this IP address is your identity card, guys. I can say this is your identity number or identity card in the large network, in this wall of network. How people know that you are this one, They will not know you through your name. They will just know you through your IP number. Okay, guys, your IP address. So it identify you in this big world. Uh, it will do this job, the first job. The second job of this network layer is finding the actual terminology is route, or actual terminology is path determination, guys. What does it mean? Path determination means finding the best route, the best route, or the best way, because now you don't know what is route. You will know it later on, but now you know way. For example, if you want to go from India to US, you can book a direct flight, or you can book a connection flight. So different type of ways are exist to go to US from India, for example. So it is the second to reach destination. Another job of the network layer is to look ahead. If there are so many routes, from you to Google server, it should select from which route it can reach faster to the destination, more reliable, not in terms of reliability, in terms of fastest route and good route. So it will do this job. How it will do this job? It will do this job through help of some routing protocols or path determination protocols. Path determination protocols or routing protocols that through these protocols it can calculate that which route is it can calculate which route is the base route. Okay, which route is the best, which route is the best, guys. So through the routing protocols, you will understand this in the really future videos. This our lecture, Ccna lecture, going to be based on this. For example, OSPF, EIGRP, BGP. So many routing protocols are available, guys. So what it's going to do is so we will add something extra here. We have okay, Control Z. Let's say let me first copy paste this. This translation layer going to be exist. Control copy. It exists. It's not deleted. The data when you are data as a network, information of transport layer is already exists. It doesn't mean that it will remove it. It will exist, but it will add not here actually. Let's say it will add it here, guys. So it will add what? So of yes, guys, IP address is IP or source IP and destination IP. If it is not visible, I'm sorry, guys. So source IP and destination IP, it will add this. Now things come to data link layer. So what the data link layer will do, guys? Please understand it carefully. When you are buying a laptop or when you are buying a computing device, the manufacturer company will add for you guys. The manufacturer company will add for you guys a NIC, a network interface card. Inside the NIC, we have a MAC address. Okay, guys, and not burned in the. Let me write it once again. The manufacturer company will do what for you guys? The manufacturer company will who has produced your laptop will include a what? A NIC, network interface card. Interface card for your computing device, whether it's a laptop, whether it's a mobile phone, or anything else. Now, this NIC has MAC address, which is a physical address born in your NIC, through electronic operations. This MAC address when does device who has been produced by this company, when this device is connecting itself with a network, where through wireless or through wire. When this device is connecting itself to a network through wire or wireless, the NIC will identify, not identify actually, will say that which type of media or medium it supports or takes. What I'm saying is, guys, the network interface card which is in your PC, it will the MAC address of this, or the information which is born there, will say, will identify that this computer can be connected if it's used by wire. If it's used by wire, this laptop, its connection is through wire, it will say that which type of media it supports, media it takes, guys. For example, if your NIC is an Ethernet technology, it cannot take the cable, the physical layer, the last layer. It cannot take the last layer of, for example, serial link. If your NIC is Ethernet technology, guys, Ethernet cable, it cannot take, guys, if it cannot take the serial cable for itself. So what is the job of NIC? The job, data link layer. The job of data link layer is to look in your NIC and will identify, depending upon the number which is born there. If it's an Ethernet technology, there's a MAC address, guys. Ethernet, there's a MAC address. So which is a really popular and famous technology. We are using this only, MAC address. So, and nowadays you will not find anywhere using other technologies like serial link or frame relay, or so many other technologies are available. So now everywhere is using the Ethernet. So you will not see anywhere the using of serial and other technologies. So the NIC will, the data link layer will see that the interface of the network interface card is currently using which type of technology, or your computing device is supporting which type of technologies. So obviously you're connecting your computer through a NIC, so it will go and find that there is, okay, so when there is a NIC, so it will have a MAC address available on it. So our data will remain same again. Control copy, Control V. Our data will remain same, just it will add the source MAC address. Okay. Now the data link layer also has the must write the MAC address of the opposite device, the other partner, because it also should know that which type of technology is available or which medium is used in physical link layer. So it will also add the destination MAC address, guys. Okay, Control Z. Destination MAC address. And one another field which is going to add is the for error control, so that if a data is missed or not, will be an error control, also a checksum value and error control, guys. So if you go deeper in this concept, it is for CMP level. So you will understand what the bit and file data will exist in error control. So I hope you understand the data link layer. The data link layer will identify which type of media going to be used in the physical layer between two devices, or which type of the medium is supported or is used in this laptop or in this computer, if it wants to establish a connection. Now it comes to the physical layer. So the physical layer is nothing but your type of media, which is already identified in data link layer. If it adds MAC address, then it's an Ethernet technology. This cable is an Ethernet cable. If there is a serial link, so it will show that it's a serial link. And if it's a frame relay, so it's a frame relay. Different type of technologies are available, guys, but almost 99%, or maybe I can say 99%, yes, are using Ethernet technology. So now this PCA has done his job, and the data is right now located inside the cable. This data, guys, this process which I have explained from PC1 side, the job of PC1 which has done till physical layer, is called encapsulation, guys. Encapsulation, because it encapsulated the data was an image only in the initial step, but later it has been become this much large data. It has been covered up with something. It has been encapsulated with extra added information, so we call encapsulated. But the receiver side, the process is totally reverse, guys. The process not from up to bottom, it's from bottom, because the data will come first to the physical layer, and what the physical layer will transfer the data to data link layer. The data link layer, the process is exactly reverse, will remove the MAC, check the error, because it has added here, it has added some error control bit, so it will use that error control bit to check whether during the transmission from this cable anything happens, anything wrong. So it will remove. If everything is fine, then it will shift the data to the network layer, and the network layer will see that whether the source and the destination IP addresses, like for example, it will check if the destination IP address is my IP address, then it will accept that. Otherwise, if it is not my IP address, then it will drop the packet here only. So now it will check the, for example, it will check the destination IP address as it's a PC2 IP address, so it will accept it, and once it accepts it, it will remove what? It will remove the IP header, IP address. Now it came to transport layer. Transport layer will first check the segments and sequence number, then the from which application it came. If the sequence number and everything is fine, it will check the source port from which application it came and wants to go where in this laptop. Now your data is related to this PC2 only. It's not related to no one else. But it doesn't mean that inside the PC2 there's only single application, so that the transport layer should directly refer that data to that application. So there are so many applications available: Facebook downloaders, there, WhatsApp messengers there, for example, so many other Chrome browsers there, so many other applications are there. So it will check the source and destination port number. Through the destination port number, it will identify for to whom this, or to whom application this segment is related. Okay, guys. So the transport layer will check this for you. Now once it understands the source port and the destination port, which is run in background, all the ports when you are using all the ports is known for this PC in the transport layer, that which application is using which number of ports. So the data will come to the session layer, and the session layer will keep the track of session, that whether it's authentication or whether it is already authenticated, so that it doesn't need for any re-establishment of the connection. So it will check, it has its own checking the presentation layer. Then now it will decode your data, because it will change the 0101 to the exact file, image file. Okay, your image file will come back again to you guys, and the data will be displayed in the application which you sent. So you're sending to WhatsApp, to obviously to WhatsApp or to Messenger, to mail, whatever you like. So the data will be good to direct to that application, and later on you can check it, or you can check it now. It's your choice. So the process was totally reversed, and if you noticed, some things are removing from the actual packet, and your actual packet now is the actual packet. There's nothing extra added when PC sent you the image. You are seeing again the same image. You are not seeing anything else or any changes on that image. So this processor, what do you think? What was the name? What should be the name of this processor? It is exactly reverse decaps. We have done the decapsulation process. So this was a good knowledge, I think, guys, for you to understand the concept of encapsulation and then decapsulation. So I think there nothing remain in this concept, but if anything was missed from me or if it's not clear for you something, please comment it. I will definitely explain this because it's really important for you guys. Comment it or mail me. It's better to comment it, I think, because other students will see your comments if they have also the same problem, their doubt will be clear, and I will definitely reply for you guys. So this was the video for today, and I hope I see you back again in the next video. Have a nice time. Bye bye.